shearing stress. Okay, so the next, let me see. Yeah. We are going to now, I mean, this is the last section of the shearing stress that you're going to learn. And it's known as longitudinal shear analysis. Okay. So for this case, the analysis, we are going to analyze the strength of joints okay, due to the shearing force V. Okay. So now the structure change. Okay, what do I mean by structure change? So this is our structure now. And what you can see in our structure over here, right? You have fastener. And if I were to draw our transformation, this is our X, Y, and rotation about Z. If we were to look at the cross-sectional view, okay, so this is the cross-sectional view now. Okay. So this is the cross-sectional view. Right? So if we were to draw transformation, okay, there's rotation about X. So if you look at the fastener, right? This over here is this fastener over here. This over here. Hey, what am I doing? Hey, undo. Okay, this fastener represents this over here. So if you look at the cross-section view, okay, what we have is we have member number 1. And then you have member number 2. You have member number 3. And you have member number 4. And all these are held by fastener number 1. And then these are held by fastener number 2. Okay. And where failure will occur is failure will occur at the joints. It's like, I mean, you guys are still young, but usually where we hurt the most is when you age, okay? It's the joints, okay? The joints always, always get hurt easily, right? If you have someone that's bigger than you and you're going to beat the person up, the way to attack that person is to attack the joints, right? You don't kick on his bones, okay? You kick at his joints. Why? Because the joints is the location of weakness. Okay. So in that context, where failure will occur, okay, the failure will occur at this point, which I'm going to draw in red. Failure will occur at the joints. Okay, always at the joints, they will fail. Okay, so always remember, I'm going to write this now. Failure will always occurs at the joint. Okay. Now, if we were to look at the formula now, okay, if we were to look at the formula now, so the formula that we're going to use, okay, is the shear flow. Which is equal, which is our Q, and this is V over I multiplied by Q, right? You know that. But this formula is also equal to the fastener resistance force divided by fastener spacing. Okay, and fastener spacing over here is S, which is the S over here. Okay, that is the fastener spacing. So if we were to look in terms of units, okay, so the units over here is Newton divided by meter 4 multiplied by meter cube. You cancel, you get Newton per meter. Force resistance of the fastener is in Newton. Spacing is also in meters. The units are the what? Are the same. Okay. Now, the next thing that we ask ourselves is how to determine how to determine the fastener resistance force. Okay. Now remember, this is one very useful topic. Okay. When I design my deck, okay, I do calculation like this. Like, what is the spacing that I have to have between my nails? What diameter of nail I should use, or screws, or how long the nail or the screws that I should be using. Okay, and it's all dependent on what load you're going to put on your deck. Okay, as I say, this is really one useful topic. Okay, so now you can see how to determine the fastener resistance force. Okay, now before we go on, in order to analyze the the shear flow, okay, this topic you also still have to design your what? Your shear flow. Okay, so I'm going to take this cross section and we are going to design our shear flow. Okay, we're going to design our shear flow. Okay, and there's a rule that I want to highlight. Okay, so we know that these are known as the members, or member number 1, and then we have member number 3 and 4. And then we have member number 4. And then this is our fastener. Okay. So we design the shear flow first. Again, the major web control the shear flow. And then in the wood, the shear flow go this way. Okay. So now, first thing to remember, okay, the shear flow rule number 1. Okay, the member or the shear flow must distribute throughout the entire member. What does this statement mean? Okay, so this statement means, I'm going to paste the diagram again, that before, okay, that before the fastener sees the load, I repeat, before the fastener sees the load, okay, the shear flow must distribute across the entire member first. Okay, okay, I better draw one arrow. It must distribute, the shear flow must distribute the entire member first. Okay, not partially. Partially means what? Okay, partially means, okay, partially means not, oh, it only need to distribute like that. No, this is wrong. Okay, it has to, the shear flow must distribute throughout the entire member. Okay, then rule number 2. Okay, rule number 2, after the shear flow distribute throughout the entire member, the fastener will then transmit the shear flow. Okay. So what does this mean? What does this mean? Okay. So let's put it at this size. Okay. So only after, right? Only after it distributes throughout the entire member, okay, then it will transmit the shear flow. Okay, so this 2 arrow over here, right, is transmit the shear flow to the other members. Okay, it will not happen. Okay, so if the shear flow is not transmitted, okay, if let's say the shear flow only, okay, only flow up to here, okay, not the entire member, when this is the case, no transmission Okay, no transmission will occur from the fastener to other members.